students, as we are seeing important questions from solution chapter, today's important question starts with elevation of boiling point and depression of freezing point. Okay, as we are talking about that elevation of boiling point and depression of freezing point, here temperature is the main concept. Vapor pressure of a liquid increase with increase in temperature. That is the main idea about these two concepts. Okay, when the temperature increases, vapor pressure of the solution also will be increasing. Okay, Raoult's law second category, you have already gone through what it is. Vapor pressure of a solution of non-volatile solute and volatile solvent always lower than that of the pure solvent. That is what it has mentioned. Right. Now, in this elevation of boiling point, further liquid boils at a temperature when its vapor pressure becomes equal to its atmospheric pressure. Okay, so the boiling point of a solution is always higher than that of the pure solvent. Now, here, for example, T naught B, that is its initial point. T naught B, its boiling point of a pure solvent. TB, it is a boiling point of the solution. This is a solvent and this is a solution. So, what is the difference between these two things means? Delta TB equal to TB minus T naught B. Whereas here, depression of freezing point, vapor pressure of a non-volatile solute and a volatile solvent always lower than that of the pure solvent. That is what both are same only. At where it varies means at a given temperature. Now here actually it's a freezing point. A liquid freezes at a temperature when vapor pressure of a solid solvent. Please note that here temperature it is reduces, that means 0 degrees Celsius. So a liquid freezes at a temperature when vapor pressure of a solid solvent becomes equal to the liquid solvent. So solid solvent and liquid solvent should be equal. Now as a result, the freezing point of a solution is lower than that of the pure solvent. Please note that here, as a result, freezing point of a solution is lower than that of the pure solvent. Whereas here, boiling point of a solution is always higher than that of the pure solvent. Here only it varies. Okay, now here let us discuss about the T naught F, that is temperature of freezing point. T naught F, that is freezing point of a pure solvent. Here, T naught B, boiling point of a pure solvent, whereas TF, temperature of freezing point of the solution. So the small difference between these two things, delta TF equal to T naught F minus TF. Okay, now a small calculation point of view, let us discuss, because generally here one more question or two more question they will ask, what is that, explain the term, and related to that some sums also they will give, that important sums also we will go for it. In this graph, vapor pressure and temperature, here A and B curve represents vapor pressure of pure solvent. CD represents vapor pressure of a solution. There is a small difference between, that is delta TB. Here, delta not B vapor pressure of a pure solvent, delta B vapor pressure of a solution. So there is a small difference between delta TB equal to TB minus T naught B. So here elevation of boiling point delta TB is directly proportional to the molar concentration of the solution. Molar concentration of the solution, here they mentioned molality. Here, why? Delta TB is directly proportional to small m. Then we have to put that constant here, delta TB equal to Kb into small m, that is molality. So Kb, molar elevation boiling point, that is a constant of molar elevation boiling point caused by dissolving 1 mole of non-volatile solute dissolved in 1000 gram of the solvent. Yes, we can complete this. Okay, now here small m represent molality, no? So WB by MB into 1000 by WA. 1000 here, 1000 grams, no? There we can take it. Now we can apply this value into this point. So delta TB equal to KB into WB by MB into 1000 by WA. Right? Okay. Finally, we can conclude this MB equal to 1000 KB WB by WA into delta TB. Right? Okay. Now the same idea we can apply here also. Whatever it is, the same thing. Only thing what it is, freezing point. Here vapor pressure and temperature. Here this, in this point, here this graph represents the frozen solvent and the liquid solvent. Here, vapor pressure of a solution. Frozen solvent, that is vapor pressure of a pure frozen solvent, and here liquid solvent. Here solution. Why? Because it is a depression of freezing point. Now here what it is, that frozen solvent and a liquid solvent. So naturally the temperature varies. So the graphs also TF T naught F, that is temperature of freezing point. So here also depression of freezing point, delta TF is directly proportional to the molality of the solution. So delta TF is directly proportional to molality. So that is delta TF equal to KB into M. M it is actually molality it has mentioned. So KB here KF, right? KF. So KF, molar depression freezing point, that is constant. Molar depression of freezing point caused by dissolving 1 mole of non-volatile solute dissolved in 1000 gram of the solvent. That is what here also they mentioned. So here, how can you bring this formula here? So MB equal to 1000 KF. That is what it is. KF, constant of molar depression of freezing point, into WB divided by WA into delta TF. I just mentioned here. TF it is freezing point. Both are same only. Only thing here, depression of freezing point, the same idea. Here elevation of boiling point, the same idea. Just we are bringing now related sums. These are the two formula we require. That is what we went this side to get that idea. Now these two formula, which is very important to solve the sums, which is 3 mark question. Let us solve the sums. Now, let us discuss important question which is from NCRT, elevation of boiling point related sum. 18 gram of glucose C6H12O6 which is dissolved in 1 kg of water. Find the boiling point of vapor pressure of the solution, 1.013 bar. Kb for water, it is 0.52 kg per mole. Yes. Now this is from NCRT, which is very important question. Now what is the formula for the elevation of boiling point? Delta TB equal to KB into small m, that is molality. So molality we have to find out that what it is, number of moles of the solute. So here glucose molecular mass, glucose what it is, C6H12O6 molecular mass, it is 180 gram per mole, right? Okay, now in that here KB, everything values let us provide. So KB for water, it is 0.52 kg per mole, right? Now here here find the boiling point. Delta TB only we have to find out. So delta TB equal to KB into M molality. For that we have to find out what it is, number of moles. So number of moles given mass by molecular mass. Given mass, how much it has given? 18 gram. So 18 divided by 180. So 0.1 m, it is small m, right? Okay. Now here delta TB equal to KB how much? 0.52 into zero point 0.1. So here what you will get it? 0.052 kg per mole. Now in this boiling point of the solution we have to find out. So boiling point of the solution, boiling point of the solution here 0.052, this one, okay, plus 373.15. How do we get 373.15? Here T1 plus T2, it's delta TB, right? So here in this 273.15 plus 100. So you will get what it is, 373. So here only we just apply. So naturally what you will get the answer, 373.202 K. So this is the final answer of the sum. Hope you got a clear idea. This is very simple sum. Okay, let us discuss another one more sum which is related to the elevation of boiling point, which is very important for the board. Now let us discuss which is related to elevation of boiling point, which is also important. The boiling point of benzene is 353.23 Kelvin when 1.80 gram of non-volatile solute dissolved in 90 gram of benzene. The boiling point of a solution is raised to 354.11 K. Calculate the molar mass of the solute. Kb for benzene is 2.53 kg per mole. Okay, now let us discuss the sum which is related to elevation of boiling point. Okay, now this is a formula. What it is? Delta TB equal to Kb into molality, right? So molality M equal to WB by MB into 1000 by WA. This is what we discussed in the class point. Okay, now here in this point, you just apply this delta TB equal to M point. We just apply this one. So here KB into WB into 1000 divided by MB into WA, right? Okay, now here MB only we have to find out because here what it is, find out the molar mass. So MB we just bring it out. So MB equal to here 1000, I just put forward here 1000 into KB into WB divided by delta TB into WA. So this is the formula we have to apply. Okay, now in this formula, what are the, we have to apply here KB for this benzene. KB, here KB for this benzene, here 2.53 kg per mole. Right. Okay. Now WB. What it is WB? Given mass of that solute. Given mass of that solute, what it is? 1.8. 1.80 gram of non-volatile solute. Right. Okay. Now here delta TB. Delta TB actually, which is they have given boiling point here one and there one raised to. So T2 minus T1 no. So delta TB equal to T2 minus T1, right? So here what it is? 354.11 K minus 353.23. Right? So what it is the answer? You will get 0.88. You will get it. Right. So delta TB also we got it. Now WA. What it is WA? Molecular mass of the solvent. Given mass of the solvent. Given mass of the solvent, it is 90 gram. 90 gram. Okay. Now here this point only we have to identify MB. So MB equal to 1000 into KB how much? 2.53 into WB 1.8 divided by here delta TB, it is 0.88 into 90. So what is the answer? You will get it. Come on. Answer it is 57.5 gram per mole. Why I mentioned gram per mole? Here they asked about calculate the molar mass of the solute. Anyway, this only we have found it, no? Yes, we got. I hope you understood a very clear idea how to solve the elevation of boiling point, which is regulate this point of the formula. Hope you got it. Now let us go for the depression of freezing point, which is related to that sum. That is also very important from the board point. Now let us discuss another one more important question. Addition of 0.643 gram of a compound to 50 centimeter cube of benzene. Density it is 0.879 gram centimeter minus 3. Density they mentioned. Lowers the freezing point. That means reducing the temperature. So from 278.662 K to 278.18 K. If KF, because this is a freezing point, no? So if KF for benzene, it is 5.12 kg per mole. Calculate the molar mass of the compound. Here, this also the same idea only. Only thing what it is, instead of delta TB, you have to apply delta TF. The same idea. MB equal to 1000 into K delta TF, no? So that is KF into WB divided by delta TF into WA. Okay, now let us apply all the values here. WA, first and foremost, let us go and discuss. So, WA, what is it? WA, given mass of the solvent. Okay, so here given mass of the solvent here, solvent means volume, it is mandatory, no? So, volume into density. Here they mentioned volume into density. So, here 50 centimeter cube into density how much? 0.879 gram per centimeter minus 3. So you will get it 43.95 gram. Right. Okay. Now WA we got it. And WB. What it is WB? Addition of 0.643 gram. Right? WA, WB, we got it. Okay, now KF. KF for benzene, they have given here KF for benzene 5.12 K per kg per mole. See, like this, if you apply the values, no, it will be easy to apply for the sum. First and foremost, you write it clearly so that you can apply the value. Delta TF. So delta TF, it is actually reduces that. See, lowers the freezing point from it is 278.66 K minus 278.18 K. Right? So what is the value you get? 0.48. Right. Okay. K value. Okay, now just apply the value all this. The MB equal to 1000 into KF how much? 5.12 into WB, what is it? 0.643 divided by delta TF how much? 0.48 into WA, it is 43.95. Okay. By this time, I think you got the answer. Just to pause that video and get the answer. Molar mass of the compound, it is 156.1 gram per mole. Hope you got a clear idea related to that elevation of boiling point and depression of freezing point, related sums also. Okay, in our next class we are going to see osmotic pressure, osmosis, reverse osmosis and related sums. All these points let us go and discuss. Thank you for watching.